This is the manufacturing process of a windshield. This process follows a number of verification steps and uses several materials which vary depending on the car model. As you can see in this video, we have an operator setting up the electrical system of the mirror together with a windshield. Bear in mind, there are different windshields for each Ford model, and each one requires a different manufacturing process. A Ford Kuga windshield will not be the same than a Ford Mondeo windshield, obviously. Thanks to our application, any supplier can show to Ford the specifics of the manufacturing process which is uploaded into the blockchain. Thus, the client can verify the correct execution of both the steps taken for assembling and the materials used. Bear in mind, 14,500 windshields are assembled every day by this supplier. Our application certifies in the blockchain all units produced and shipped to Ford. Between the supplier and Ford, there are no people. They are all robots. If there is any defect when robots pick up the windshield and install it into the car, they stop the line. Then the supplier has to justify what has happened. Stopping the line of a car manufacturer, as you can imagine, entails a strong penalty, so this has to be avoided at all costs. In this table, we see all steps of the production process of every windshield, specifically the reading that is expected to be received, the reading received by the IoT device, and finally, if the result is okay or not okay. Let me give you an example so you can understand me. As you can see now, in the third step it says protect corner. When the video starts, this operator protects the corner with a white cover. If this glass arrives at Ford without this protection on the corner, the supplier can prove that he has put the corresponding corner protector on it. Therefore, the error has occurred on Ford's part when handling components. In addition, as you can see, the application has marked OK in the database. All this is uploaded in real time to the blockchain network, so whenever an operator wants to inspect the manufacturing process of one windshield, he can do so by scanning the QR code. Our platform has the particularity of being a multi-blockchain platform. This allows the use of more than one blockchain network depending on the project and the specific needs of the client. We can work with VeChain, Bitcoin SV, Blockchain Fua, Alastria, among many others. It is important to note that we have two ways to upload data to the blockchain. On the one hand, we can upload raw data. Let me show you an example for you to understand. Here you can see the 6 stages of the supply chain when delivering an order. Each stage has a timestamp that is recorded in the blockchain thanks to IoT devices. Let's remember the previous operator manufacturing windshields. Whenever he finishes an order, he puts it in a container which is shipped to Ford. Every one of these stages is where that windshield has been passing through. In this case, all this data is registered directly into the blockchain network, since it is a plain text that does not take much storage space. In other words, in the public blockchain network, we could see the words exit, loading dock, and its timestamp. On the other hand, whenever there is a significant amount of information to be uploaded into the blockchain, such as videos, we use hashes. We have to take into account that a video is being recorded every minute. For example, if we take a look at the application, now it's 4:20. At 4:19, there is already a recording. At 4:18, another one. At 4:17, another one, and so on and so forth. If we were to upload all these videos to the blockchain, it would cost us a fortune. That is why, to solve this, we use what is called hashing through SHA-256 algorithm. But what does hash mean? All information that I have marked in blue and is registered on the network is hashed through a page available to everyone where the information is encrypted, which is what I show you below. Don't worry, this is very easy to understand. To validate that the information shown in the application is the one previously uploaded to the blockchain network and no data has been modified, there is a simple process to follow. What we do is obtain the traceability data, which is the data set in the table together with the video. This set of information is hashed through SHA-256, and as a result, a hash is obtained. Then, to validate that this information was the one previously uploaded in real time, we compare the hash obtained with the traceability hash given by the application. If both numbers are the same, we can prove that the information uploaded to the blockchain is the same. In fact, as you can verify, both numbers coincide. To demonstrate that, we are going to do a minor change in the dataset information in the web of SHA-256. Specifically, we are going to include a comma and see what happens. You see, now it's a totally different code and we just added a comma. So if I add a comma to this information that I have given to Ford, you can see that the hashing is totally different. Even though raw information such as videos are not directly uploaded to the blockchain, there is a hash which proves that the information that was uploaded is exactly the information being displayed.